Hello, everyone. My name is Szozda, and I'm a paintings conservator and a PhD candidate at the Academy of Fine Arts in Warsaw. Today, I'd like to share part of my ongoing research on how magnetic fields interact with graphite and what this means for artworks that contain it. I'll do my best to show how this research bridges material science and conservation practice, and how magnets can become safe, intelligent tools that we actually can use. This presentation builds on the research poster I had the honor to present at the conference in Louvain this year. So let's start with this basic question: why is it important to talk about magnets? Um, I'm sure, as you've noticed, they've become an intelligent, reversible tool in conservation. We use them for mounting, for framing, stabilization. They're clean, reusable, and sustainable. Uh, but while magnets feel safe, their interaction with fragile materials, like, for example, graphite, is still not fully understood. We talk about this because innovation in conservation should never be blind, and even invisible forces deserve attention, especially when they touch the surface of an artwork. I personally believe that magnets can be brilliant, but we need to understand um, how they actually work and what they really do. Since the 1980s, around that time, magnets, since then, they are increasingly used uh, in museums, galleries, conservation studios, for mounting works on paper, textiles, paintings, sculptures, artifacts, you name it. They offer many advantages, but they also introduce new types of forces that may act on the object, and that's where my research begins. The whole project started with curiosity. During a pigment identification class, I once brought a magnet close to a jar and then to another, and so on, and I saw movement. The first one was cobalt blue, a paramagnetic substance. So many years later, I returned to that question, this time systematically, and I began studying how graphite, pigments, and paints behave near magnetic fields or in the magnetic fields, and how this knowledge can serve conservation. These experiments evolved into my PhD project, uh, which basically touches the problem of practical usage of magnets in conservation. Uh, I think it's also worth noting that nearly all materials in nature show some kind of magnetic behavior. It's diamagnetic, paramagnetic, ferromagnetic, and understanding these properties help us predict how materials might respond to magnetic fields. Uh, Here you can see a graphite stick being attracted to a magnet. And although we normally would think of graphite as diamagnetic, certain types, especially drawing graphite, can show a weak ferromagnetic response. Uh, and it's due to impurities or processing residues. The movement you see here is a simple but clear example of how graphite can react to a magnetic force. When we repeat the test with powdered graphite, uh, we can see something even more striking. The tiny particles align themselves along the magnetic field lines, and it's almost like iron fillings. And this confirms that this graphite contains ferromagnetic components that respond visibly to the field. So, what I actually did was I took woodless graphite. I used just sandpaper and tried to get the fillings, shavings, something tiny. and that's what you could see here at this on this video. But it's also worth noting that it's not always the graphite itself. And in this particular example, a woodless graphite stick, the pure graphite core shows no attraction. However, when we turn it around, the foil casing reacts strongly. And this is caused by the ferromagnetic contamination in the sleeve. So it's a good reminder that sometimes it's not the medium itself, but the surrounding material like foils, metal dust, or packaging that can react to magnets. A magnetic field, what is it actually? It's this invisible area of force surrounding a magnet. And let's not get into a lot of details, but I'd like to mention that the magnetic field is obviously strongest uh, near the magnet, but especially near the poles. So that's where the biggest force will be. And the magnetic field has this property that decreases very rapidly with the distance. And of course, the field depends on the magnet size and configuration, which means that different setups can create very different effects on artworks. But let's remember that even if we can't see it, the field can still influence materials within its reach. To understand the strength of magnetic fields, open access calculators can be very, very helpful. So they estimate field intensity based on the magnet's type, size, and distance. These tools presented here, the links to these tools presented here, were created specifically for us, for conservators, to help assess magnetic interactions safely and efficiently. So, what this actually allows us to predict is, even before testing, is whether a particular setup can work and can it actually pose a risk to the artwork. Basically, obviously, the stronger the magnet and the closer the distance, the higher the field and therefore the potential interaction with materials like, for example, our graphite. Uh, let's talk about the graphite in the magnetic field. So, what happens when we actually draw? When we draw with a pencil, we rub a layer or layers of graphite onto the surface, and that layer, which remains, is loose and it's not bound by mediums, like, for example, with oil in oil paints. So it is therefore more fragile. Figure A, the schematic shows the layered structure of graphite, and small amounts of iron atoms can appear between graphene layers as intercalation compounds, and these are responsible for the weak ferromagnetic behavior we sometimes observe. Photo B shows how the fine graphite dust immediately clings to the magnet. It's literally coated the magnet by particles. And photo C shows a magnet that holds an entire paper sample. And that is a piece of paper coated with graphite, like drawn and the layer itself becomes magnetized and suspends the whole sheet. So even though we usually, as I mentioned that earlier, of graphite as dia or even non-magnetic, we clearly see that under strong fields, uh, it can behave very differently. To evaluate such effects more systematically, a magnet risk test was developed. The study had four main goals. First, to assess how magnetic fields may influence graphite based drawings. Second, to visualize these interactions and make them observable. Then to develop a simple classification system describing levels of magnetic susceptibility risk. And finally, to propose practical guidelines for safe handling and mounting. Here I'd like to show you how it actually works, this test. So a light paper strip coated with a drawing graphite was fixed at one end and placed close to a neodymium magnet. And the magnet is positioned at or just below the strip's free end. If the strip moves or bends towards the magnet, it indicates magnetic attraction, obviously. And based on this reaction, we can assign a risk factor. R equals 2 means strong attraction or suspension, therefore a high magnetic risk. And then if we move the paper, the risk factor will now be 1. It will be moderate, and we can actually assess that the risk is medium. And if we move it even further away from the magnet, the risk will now be 0, which, as you can see, there is no reaction at all, and obviously no risk. And this is a very simple setup, but it's, I think, a very good visual setup, and it quickly allows us to compare how different graphite layers, because we can of course change the layers, and the distance, we can also change that, how these respond to magnetic fields, how these samples that we would like to test will react. And with all that in mind, I think it's fair to say that magnets can be both powerful and safe, even for delicate materials. With controlled distance, balanced pressure, and thoughtful design, they can become smart, reliable tools in our conservation practice. And of course, when used with care, they give us more flexible ways to display and protect artworks, and give us new possibilities which are safer and cleaner and sustainable. Uh, my goal is to keep developing and sharing such magnet safe solutions. And if you're exploring any magnetic challenges, I'd be very happy to connect and exchange ideas. I am very curious about your experience. So, to wrap things up, I think I'd like to say that we often think of materials in artworks as non magnetic. But in reality, even inert materials can respond to magnetic fields. The magnet test offers a new way to visually assess that interaction. And of course, new research is still needed. Uh, what we also need, I think, is a sort of safe handling protocol. Uh, because understanding these invisible forces uh, helps us prevent potential risks uh, to our artworks. And now we've reached my absolutely favorite slide, the one with the main message. So, with understanding and care, magnets can safely enhance our conservation methods. And luckily, our magnets stay on the light side. So, thank you, and may the force stay gentle with your artworks. Thank you so much.